Hello, everyone. I just wanted to welcome everyone to the Disease Impacts Forum, of part of these climate and health sessions that we have. And the purpose of these is to support researchers from all divisions working at the intersection of climate and health so that we can talk together, discuss shared research interests and develop a common language for delivering some interdisciplinary funding applications. If you have any technical issues, please do contact Tristram or myself via the direct messaging on AirChat, or use the purple question mark button on the bottom right-hand corner, which gives you 24/7 access help to the AirMeet staff. The panelist session is going to be recorded, but not the breakout rooms discussions. They're not recorded. We won't be taking questions at the end of the panelist talks due to time. So do hold any questions you have after listening to them and take them to the breakout tables. I'm now hopefully going to introduce Jim, who's going to open as the chair. Jim Hall is the chair of the whole forum series. And I'm going to introduce Jim, and then we'll pass on to Sophie Yacoub from Vietnam, who's is chairing this session.
Thank you very much indeed, Joe. Morning, everyone, or good afternoon, Sophie, and anyone else in further east than we are. Great pleasure to be welcoming you to this series of climate and health forums. My name is Jim Hall. I'm Professor of Climate and Environmental Risks in the Environmental Change Institute, and I'm also a convener of the Oxford Networks for the Environment, which, as I hope you all know, bring together research and education across the fields of climate, water, food, biodiversity, and energy within the University of Oxford. One is supported by the MPLS division, by the Oxford Martin School, and by the School of Geography and the Environment. And we seek to facilitate ambitious and, in many senses, interdisciplinary research on those grand environmental challenges, provide a shop window to the rest of the world so that they can possibly understand the sometimes bewildering Oxford landscape of an enormous diversity and breadth and flourishing of environmental research in all its senses, and also help us to connect up internally within Oxford to understand what we're all up to. And so when Joe and others started thinking about this program on climate and health, it was entirely appropriate that one should help to facilitate these seminars and workshops. And I'm most grateful, in particular, to Tristan Walsh, who stepped in, coordinator of the Climate Network, to help out alongside Joe and Nevin, who's been leading these the organization of these seminars. Climate and health is so multidimensional that we've had a variety of different cuts in terms of thinking about how we carve up these different seminars, and what we arrived at, I hope, has some logic to it. In the one today we're having today, the focus is on disease in all of its various guises, from vector-borne diseases, infectious diseases, through to forms of ill health around diet and nutrition, questions of water and sanitation, air pollution, mental health. That's an extraordinarily broad range. But that, in a sense, is only one take on how we can think about this climate and health system, because we go on to look much more at healthcare systems, their vulnerabilities to climate change, both in chronic and extreme senses. So the impacts of extreme events, but also more chronic effects, for example, on heating in hospitals and care homes, and also looking at humanitarian systems. And then we're finally looking at the effects of climatic extremes, which is something there's a great deal of work going on in Oxford, and understanding some of the extreme health and humanitarian impacts of what we can expect from climate in the future. So promises to be a very interesting series of meetings. Partly, as Joe has hinted, we're hoping that as well as new collaborations, there will be new funding applications coming out of this. There's a particular focus on the Wellcome Foundation and their identification of climate and health being one of their main themes going forwards, though that exactly what they mean by that is still apparently taking shape. But I think it makes a lot of sense for us within Oxford to be gearing up now. Clearly, Wellcome is an enormous funder of research in Oxford. And so one of the goals of this seminar series is to begin to both make relationships and spawn ideas in terms of what we might do in response to Wellcome and other funding opportunities coming up, because we all know that when these things do come out, they often come out with an alarmingly short timescale, and you're more successful, you're going to put a better proposal together if you already know the people you want to be working with and you've already got some ideas about what you want to do. So part of what we're aiming to achieve today and in the subsequent seminars is to provide a space for that interaction to take place. And finally, I should thank the speakers who have agreed to say a few words today from a very wide variety, and looks like a fascinating number of different perspectives around this question of climate and disease. Some of you were pulled in at relatively short notice, so thanks very much indeed for being so amenable to that, and for agreeing to share your thoughts with us. And with that, I think I will hand over to Sophie.
Thanks, Jim. That was a great overview. And yeah, I also just want to say thank you very much to Joe and the team in Oxford for organising this so quickly. It's an amazing feat. And there's such a broad range of people here, which is amazing. So yeah, I'm Sophie Yakub. I'm actually an infectious disease clinician. And I'm based at the Oxford University Clinical Research Unit in Ho Chi Minh City. So I think I'm really here to represent a lot of the team over in the Africa-Asia units. My research is based on dengue, so there was a clear link with vector-borne diseases and climate change, which is really an area that we're just starting to do in OCRU, and I think the other Africa-Asia programs are the same. But I think we've got various people from those teams here today. And you'll hear from Mark Choisy, who's head of modelling at OCRU, and various of the other panelists. But I think what the main aim of this forum today is really to bring together the expertise that we've got in Oxford, which is huge, but also to remember that Oxford have these overseas programs in Kenya, Thailand, Vietnam, Indonesia, and also Laos, Cambodia, and Myanmar. So trying to connect everybody together today, I think, would be a great outcome, because as Jim and Joe have mentioned, the Wellcome Trust are focusing now on climate and infectious diseases, which I think really the intersection is so important, especially for where we're based in Southeast Asia, where climate change really will be felt by so many people, and already is, with extreme weather events happening in Vietnam and Thailand in the last few years. So it's really just my job is just to try and bring everybody together today. I'll be flitting through the rooms through AirMeet, and just trying to facilitate some discussions and trying to get what is really an amazingly multidisciplinary group of people together with the aim of getting new collaborations and going on to get one of these pump priming awards, and then a bigger Wellcome Trust grant. So that's the aim of today, I hope. And I will stop talking, and I'm going to hand over to some of the panelists to give a brief introduction of their research areas, and they will then be leading each of the AirMeet rooms. So I think I'm going to go now to Professor Philip Steer, who will start. Thanks, Philip.
Great. Hello and good morning. I hope you can hear me, and I hope you can hear me a bit longer because we have some building work behind me in the office. So there's a jackhammer going off right next to my ear. Let's just start. I have some slides to share. Great. I hope you can see this now. It looks like it's sharing now. Great. So you might wonder what air pollution has to do with climate and health, and I just briefly want to show a few images, really mostly around it for the people who are not climate experts. Just coming to climate and air pollution. So air pollution is obviously abundant. It's so abundant that you can see it from space. So this is a satellite image of Europe, and you can see big areas of air pollution all across, including mineral dust blown around and fires and many other bits. But what does it mean for climate? The fact that you can see it from space already tells you that the sunlight that falls on the Earth gets reflected or scattered, as we say, by these air pollution particles, by aerosols, back into space. And you can quite easily imagine that this is a cooling effect on climate because less radiation stays within the Earth system. To make things a little bit more complicated, these air pollution particles also change the appearance of clouds. And what you see here is a satellite image over the North Atlantic, and you see these near linear features embedded in these cloud decks. And what it effectively is, it's tracks of ships that emit air pollution particles, aerosols, into the cloud deck. And each of these cloud droplets forms on an aerosol particle. And where you have more air pollution, you then have more particles and with smaller droplets. And these make clouds brighter, as you can see by these really bright tracks here. And this is also illustrated at the bottom. So again, this is an effect that makes clouds brighter, reflects sunlight back to space, and will cool the Earth system. So how much cooling? And this is a figure from the latest Intergovernmental Panel on Climate Change report that attributes the observed warming to greenhouse gases, shown here in the big red bar. And just notice that the greenhouse gas warming alone at the moment would be at roughly 1.5 degrees, so already at the Paris Agreement target. And the only reason why we're not there yet is that a good part of this warming is offset by this cooling from aerosols. And also note that the big error bar here of the cooling from aerosols, that really drives the overall uncertainty. So why does this matter? Well, air pollution kills an estimated 7 million people worldwide every year. And obviously there's a good reason to get rid of air pollution. But what does this then mean for climate? Obviously, effectively, it means we would remove this cooling effect of air pollution on climate, and we would accelerate warming. And that is obviously sort of a moral question you have to pose. And yeah, 7 million people killed by air pollution isn't an easy thing to trade off. So just to add to this, this is sort of the global picture, but just coming a bit more regionally and looking at other effects of climate change. So one thing we obviously know is that climate changes temperatures, but in particular for diseases will be important. How does it change climate extremes? And this is just a synthesis of these, this is a very coarsely drawn map, if you notice. So you see basically the continents shown here. And you see here the change in hot extremes and the confidence that these assessments put on the change in the extremes. And you see that pretty much worldwide, you expect an increase in hot extremes. And the confidence is relatively robust on temperature. So that's something we can take to some degree for granted, but it still is, there are areas where the uncertainties remain high. But what I find quite shocking when you look at the same map for heavy precipitation or for precipitation in general, for much of the world, we don't exactly know how precipitation is changing. And we have only some areas where we have confidence that our change in heavy precipitation is we can robustly attribute it to climate change and the different drivers of climate change. And one reason for that is simply that also our current climate models are very good and that they have tremendous skill, but they also have shortcomings. And the shortcomings are quite a bit around the area of clouds and the associated precipitation. And I'll stop here, but I just want to briefly say that in the physics department, we have quite a bit of expertise on some of these areas. And if people are interested in working with people, so there's a lot of expertise in climate dynamics, predictability and extremes, also climate predictability and the associated risks. We do a lot of climate modeling, in particular also this next generation climate modeling, where we really try to improve clouds in these climate models. And as I already highlighted, there's also air pollution and climate is an interesting area of research. And I'll stop here and hand back to the chair.
Thanks, Philip. That was a great introduction. I think let's move straight on to Marc Choisy, who'll talk about his Vietnam.
Hi, everyone. I'm going to share as well. But you should see the slide. So yeah, Marc Choisy. I'm based at Oxford University Clinical Research Unit in Vietnam, and I'm the head of the mathematical modeling group there. So I'm studying mostly the transmission of infectious disease in population and using mathematical modeling to better understand that. So infectious disease, there are all those diseases caused by a virus, bacteria, any other sort of organisms that are basically transmitted from people to people. And it could be transmitted directly, like measles or influenza, but it could be mediated by a vector, like a mosquito, like in dengue and malaria. It could be transmitted through the environment as well, water, soil, or any other things. And it could get in the human population in the first place from animals. So that's the case of zoonosis. And so in the context of, in that broad picture, climate can basically influence any of those arrows that you see on that slide. So it can influence, for example, the survival of the viral particle in the air. It could also have an effect on the population dynamics of mosquito and so on and so on. And I've put in blue saying that the environment itself can also affect directly the population dynamics of mosquito, or can affect the wide population of animals and increase the probability of zoonosis, for example. So if we look at the effects of climate on these different things, there could be direct effect of temperature, humidity on the susceptibility to people to a given virus or the survival of a virus. But there could be also indirect effects. For example, climate change can also trigger some environmental change. It can change the behavior of populations, triggering population movement, deforestation, and also biodiversity loss. And even more complex than that is that whenever we're looking at the relationship between climate and infectious disease, it's getting complicated because of the temporality of the relationship. What's the temporal and spatial scale we are looking at for this effect? But also because of the complexity of this relationship, as I show on the right-hand side of the slide. well, it could be linear, but also non-linear and quite very complex actually. So very much understanding the relationship between climate and infectious diseases, also trying to dig into detail into the shape of those relationships. And so this is for climate and infectious disease. But then when we ask the even more complex question about climate change and the effect of climate change on infectious disease, we add another layer of difficulty, which is kind of forecasting what's going to happen in the future. So there's different approach to do that. Do we do interpolation, extrapolation? Do we try to run a correlation-based or statistical model versus more mechanistic approaches, which also involve trying to get to know better what are the mechanisms behind the phenomenon that we observe. So that involves either observational studies or experimental studies, sometimes in the lab. And so you really need a wide variety of approach to hope to get to better understand those things. And so, as I said, we're based in Vietnam. So, and I mean, climate change and climate and infectious disease has never been my main topic of research, but I kind of got interested in running some project, like side project, because obviously I'm interested in transmission of disease in population. So here on that slide, I'm showing Vietnam is very interesting actually to address those questions because it's got so high diversity of different climates on such relatively small country. That's because it's got a very wide latitudinal range and also elevation range, so which is cross perpendicularly. So it generates a wide variety of climates. And this map shows that this is the result of a model that we fitted in Vietnam to explain the seasonality of influenza. And then we use that model fitted in Vietnam to predict the seasonality of influenza all around the world. And we got a very good performance of that model, just to illustrate that we got so much climatic diversity in Vietnam that we can easily extrapolate to the rest of the world, at least for some disease. Also in Vietnam, we've been in Vietnam for many years. So cruise was started 30 years ago. So over the years, we've managed to accumulate quite impressive data, like this figure showing dengue incidents over 18 years across 8 countries in Southeast Asia and in 273 provinces. So it's one of the largest, if not the largest, epidemiological data set on dengue. So it's amazing. Then you can basically analyze it with also similar data, climatic data, and try to understand, even with some correlation, to see what are the correlation with climatic variables. And so in Vietnam, in terms of climate change, there is obviously increased temperature, but also Vietnam and Southeast Asia, and also increased sea level, which is a big problem, as Vietnam's got 2 main delta, Mekong Delta and Red River Delta, on which the whole population depends a lot for agriculture. And those delta are becoming more and more salty because of increased sea level. Also more and more frequent floodings. And so Southeast Asia in general is characterized by very large population and a very fast urbanization rate. And in terms of infectious disease, so 2 vector-borne disease, dengue, malaria, influenza, also many infectious diarrhea that could be linked to the environment, to the flooding, and also the sort of environmentally transmitted disease, rickettsial infection, and so on. And to finish, I'm showing this study that we did to show, to illustrate the fact that what happened in Vietnam has got consequences on other regions of the world. So this figure is showing the importation of dengue in different cities of China from different neighboring countries. And you see Vietnam is well positioned. But even within Vietnam, we see, when you look at dengue, for example, that the epidemiology of dengue in the north of the country is very much driven by the epidemiology of dengue in the south of the country, which means that any climate influence of dengue in the south of the country can potentially have consequences also in the northern country and the rest of everywhere in the country. So the link between climate and infectious disease could be it could happen locally, but also it could propagate in space just because the infectious disease move in space as well. That's it for me.
Thanks, Mark. That's great. And if anybody's interested in hearing more about infectious diseases or Southeast Asia, please interact with Mark in the breakout room later, or myself. So we're going to move to Peter Scarborough now, who's going to talk about nutrition and diet on climate.
Thanks, Sophie. I've just got very few slides to share, so I'll just do this just a second. Okay, I'm going to assume you can see that slide. Right, okay, so yeah, I just want to talk about diet and nutrition and climate change, but not just climate change, because diet and nutrition goes much further than just climate change, because agricultural food systems have massive impact on the planet beyond just climate change. So this slide kind of sums this up to some degree. We know that the food systems, agricultural food systems, contribute about 1/4 of all global greenhouse gas emissions, but also they take up about half of all global habitable land. The rest, of course, is kind of forests and a small amount of kind of urban area. And of course, as we're needing to expand agricultural land use, then we're talking about having to remove forests, which obviously has a massive knock-on effect for greenhouse gases. Obviously, it's a major player in terms of fresh water use, water availability, and also it's the major contributor to water pollution worldwide. And obviously, in terms of what we talk about with deforestation and with the way that global agricultural systems working these days, it has a massive impact on biodiversity. So loads and loads of issues that are related with the global food system that are beyond just climate change in terms of when it comes to the environment. And of course, when it comes to the environment and what impact the global food system has on the environment, it isn't about where the food is produced particularly, it's more about what type of food is being produced. So we know very clearly that, that animal-based food consumption, particularly ruminants, so cows and sheep, have a far higher environmental footprint than production of crops and fruit and vegetables and cereal crops. So this is some work that was done in Oxford by Joseph Poor and his team, which is basically it's a review of many different life cycle assessments across the food system, which just look at try and look at what is that distribution, what is that range of environmental impacts across a whole range of different environmental outcomes. And the real key thing to see here is this shift in the red line, once you've got past beef and lamb. And go down into to other animal-based foods, and then you're on the plant-based foods much further down to the left. There's real order of magnitude difference, and the reason why is well, there's a couple of reasons. One is because particularly with ruminants are producing greenhouse gas emissions of their own. So in terms of methane that is produced by ruminant animals as they live. But it's mainly because of just inefficiencies in the system. So so animal-based foods are being fed on crops which could have been used for human consumption. So that inefficiencies in the system just basically collapses it all into this position where your animal-based foods have a far higher environmental impact than plant-based foods. And what this means is that we're going to have to do something serious about the food that we're eating if we're going to have any chance of meeting climate targets. And the reason being, because at the moment, animal-based food consumption is going completely in the wrong direction. As countries are moving, as they're developing, as economic disposable income is growing around the world, we're seeing a move towards increases in consumption of meat and dairy products in most countries around the world, most economically developing countries around the world. And that just means more and more pressure on our agricultural land system. So if you follow the business as usual trajectory of agricultural food systems, then from food alone, even if all other emissions were stopped immediately, food alone would be enough to take us over the Paris Agreement 1.5 degree target. is it enough to just do technological changes? Are there ways of kind of closing yield gaps, of reducing the amount of environmental impact from a unit of food production? Well, yeah, you can make some differences there, but to get it down to the point where we're actually going to stay within the climate limit, you can't avoid the fact that you need to actually be changing the type of food that people eat. And when I say that, it's very easy to kind of look and say, okay, well, you know, the economically developing countries are on this high trajectory of animal-based foods, but they're still miles lagging behind where the rich and the developed countries are. So it really, it's almost like this kind of a convergence and contraction idea where we need to, in the richer developed countries, be reducing animal-based food consumption and meeting at a kind of lower levels which are consumed in more economically developing countries. So if I just stop sharing for a second, I'll just tell you a little bit about the work that we're doing at the moment. If I escape from that. So like I say, a lot of that work is going on in Oxford at the moment. And what we're doing with a project called LEAP, which is about livestock, environment and people, which a number of people on the call are involved in, is looking at saying, how do we model how do we look at the potential impact of different global food scenarios on nutrition around the world, because obviously you've got very different issues that you're looking at in different countries around the world. Looking at the long-term health impacts of those global diets, looking at their environmental impacts, and looking at matching those models up, integrating them with global agricultural economic models so that we can get realistic scenarios of what's happening into the future and in different situations if different interventions were put in place. And increasingly what we're moving on to do is to look at saying, okay, rather than just kind of hypothetical scenarios about saying, okay, well, what happens if a tax was introduced here or tariffs were introduced here or what have you, looking at actually seeing, well, what changes could we actually do within specific countries that are actually going to have an impact on people's animal-based food consumption, and then modelling through and saying, well, what impact could that have in the long term on both health outcomes and on environmental outcomes? So those are the kind of questions we're interested in answering in the project that I'm involved with. So that's a quick overview, and I'll just pass you back to Sophie.
Thanks a lot, Peter. Yeah, please join his breakout room discussion on this more later. So we're going to move to Mike Rayner, who will talk about non-communicable diseases and the work he's doing.
Great, thank you very much. Can you hear me okay? Yep, good. Okay, so I'm Mike Rayner. I'm a professor of population health in the Nuffield Department of Population Health at the University of Oxford. And I'm also a director of a WHO collaborating centre on population-based approaches for non-communicable disease prevention. So what do we mean by non-communicable diseases? Well, the WHO really thinks of non-communicable diseases as cardiovascular disease, cancer, diabetes, and chronic obstructive pulmonary disease, but also is increasingly concerned about mental health and accidents as a form of non-communicable disease. What do we mean by population-based approaches to the prevention of these diseases? Well, in our group, we're looking at things like food taxes, food labeling schemes, restrictions on the marketing and promotion of unhealthy and increasingly unsustainable foods. So my group over the last 15 years has looked at both the impacts of means of both at preventing ill health through non-communicable diseases, but also improving planetary health as well. So our concern really is to come up with policy-based solutions to both population health and to planetary health. So, of course, as Pete, who works in my group, has just described, we're mainly interested in diet, but we're also interested in other factors which determine lifestyles like tobacco smoking, alcohol smoking, and increasingly in things like climate change and how that's going to have an impact on things like on non-communicable diseases. So in the breakout session, I'm hoping we can have a discussion about how we see the future in terms of climate change and non-communicable diseases. To me, it's not entirely clear, for example, how climate change is going to affect cancer rates across the globe. But given that cancer is a major cause of disease across the globe, both in low and middle income countries and high income countries, we could expect to see some changes. So that's what I'm hoping to get out of today, to learn from more of you about how you see the impact of climate change on non-communicable diseases such as cardiovascular disease and cancer. That's me. Thank you.
Thanks, Mike. Yeah, that's really interesting and looking forward to those discussions. So we'll move on to water and sanitation now, and Katrina Charles is going to introduce that area. Katrina?
Thanks very much, Sophie. So the recent sixth assessment report from IPCC has highlighted that climate change is intensifying the water cycle. So we're seeing more extremes of wet weather and of dry weather. And these are increasingly challenging, well, creating floods and droughts, but they're challenging how we manage water. So one of the big issues for adaptation is to improve water management to address this. But when we change water management, we also change health outcomes, and we do that in many different ways. So if I just focus, for example, on drinking water, we often think of drinking water in relation to health of just being diarrheal diseases, and that is certainly still a major issue. And we see particularly outbreaks in both wet and dry seasons and wet and dry extremes through different mechanisms. And this also relates to health outcomes such as stunting and links into non-communicable diseases through that pathway as well. But there's many other ways that water, and even just drinking water access, impacts on health. So for example, there are water access related diseases related to not enough water for hygiene, or for example, not wanting to wash hands in cold weather. There are musculoskeletal issues related to water carriage, so increased in droughts where people are walking further and more difficult journeys to collect water. There's musculoskeletal impacts there, and also attacks during collection of water, including gender-based violence issues. There is increased growth of certain organisms in hot weather, which some of the speakers have already mentioned. So we have algal blooms as one of the ways that water impacts on health. And there's also vector-borne diseases. So that was, Mark mentioned this, but also for water access, we've seen in previous droughts, as people change their storage habits of drinking water, you get increases in mosquito breeding and dengue outbreaks. And finally, there's also mental health issues associated with lack of water, lack of access to safe water, so good water qualities, are all different ways in which water impacts with health, and that will change with climate change. We're particularly interested in our work in how we achieve and how we sustain a high level of water and sanitation service. And that includes maintaining that through climate variability. So how do you change the organizations that are providing these services so that they respond when there's a breakdown, so they respond when they know that the water quality has deteriorated? Because it's not just whether someone has water and sanitation, but it's a level of service they have. If they have enough water, if it's convenient, if it's safe water, and so many other aspects within that. And particularly where I'm interested in is water quality. So we know that drinking water quality deteriorates with heavy rainfall. Even in Europe, we have outbreaks associated with heavy rainfall through piped water systems. In developing contexts, there's already poor climate resilience within water systems. So they're very vulnerable to changes, even in seasonality, and certainly to climate extremes as well. I think three of the key issues that I would throw out there in terms of opportunities in the field, in terms of water and sanitation and health, one would be, how is climate change impacting the quality of health services via water and sanitation? So we've been working in healthcare facilities, and they typically, if they have water and sanitation systems, they have poor management of them. So there's almost no literature on how climate change, how extremes are impacting those health services that are available to people. There's some small levels of evidence, for example, high temperatures affecting dialysis machines. There's impacts via algal blooms, again on dialysis patients, but generally there's poor evidence of those. There's increasing, with sea level rise and with agricultural development too, there's increasing issues around salinity in drinking water, and the impacts to health are not particularly well understood. There is evidence linking salinity in drinking water with eclampsia, hypertension, and miscarriage, but there's certainly a lot more room for more evidence, because this is going to be a really big problem going forward. And then finally was, how do droughts affect health in urban areas? This is something I've been looking at, where there's very little evidence. So we've had major droughts, for example, in Cape Town that affected availability of water, but there hasn't been much analysis of that health impact. There's been some very small ones on hospital admissions, but there really is a big gap in some of those big database retrospective analyses. Across the Oxford, we've got the Oxford Water Network, and there are people working across Oxford on all sorts of issues to do with floods, droughts, water and wastewater treatment, and hydrology and much more. So I'm very happy to discuss with people how you might bring water and sanitation into your project, and water management more broadly. Thanks very much.
Thanks, Katrina. A very broad area. We're going to go now to our last of our panelists, called Lawrence Wainwright, who will talk about mental health. Lawrence?
Good morning. It's a real pleasure to be with you. Can you all hear me loudly? Can someone give me a thumbs up?
It's fine.
Fantastic. Thank you. Thank you very much. So the first thing I'll say is the prevalence and impact of psychiatric illness. So psychiatric illness globally is both high in prevalence and high in cost. In this country alone, in England, 1 in 4 people in an average year will experience some sort of mental health problem. Globally, we're talking about 270 million people affected by depression, a further 45 million by bipolar. The global burden of that, 32% of years lived with disability and 13% of disability adjusted life years for psychiatric illness, so very high cost. Economic impact just in the United States alone of depression is $120 billion, which is about 20% of their defense budget. Mood disorders have the other disease group with the second highest burden of all. Suicide is the leading cause of second leading cause of death amongst 15 to 29-year-olds globally. So we have a problem already, even before climate change. Now, the first thing I'll say very quickly is the psychological consequences of climate-related disasters are very significant. Individuals who have been exposed to life-threatening situations are at considerable risk of developing post-traumatic stress disorder. There's also an increased rate of suicides after disaster. I had a nice slide here, which you can't see, on Hurricane Katrina. This is quite startling. 49% of those who remained in New Orleans after the hurricane went on to develop a mood or anxiety disorder, so huge numbers there. In terms of general angst and anxiety in this country, 60% of people approached, of young people approached, said they felt very worried or extremely worried about climate change. More than 45% said that those feelings affected their daily lives, and that's quite significant to think about. Suicide and climate change, a study this year, Heo, Lee and Bell, found a significant and positive association between daily high temperatures and suicide, which is quite concerning, because obviously climate change is going to increase the temperature. Now we look at something like seasonal affective disorder, or seasonal adjustment disorder, as it's sometimes known. There's many unknowns here, but theoretically, it's likely that climate change will have implications for this disorder, which affects millions. I mentioned bipolar disorder before. There's many unknowns here. But what we do know is that 2 climatic / weather variables, evaporation and temperature, may account for annual fluctuations in mania. So bipolar is a condition where there's, in bipolar 1, there's periods of mania, hyperelevation, hyperarousal. In bipolar 2, it's called hypomania, followed by depressive phases, and then people are asymptomatic half of the time. But if we are to see spikes in levels of mania, this is also the period of the disease where most people take their own lives. So there's very, very serious implications there. Now we go into something like a loss of livelihood and or relocation. So we're talking about droughts. We're thinking about farmers, occupations that are very, very dependent on climate, and the implications around climate refugees and forced migration and the mental health implications of that. Many communities already being affected already. Gibson et al., their study of some of the Pacific Islands, they found that a high proportion of participants are experiencing psychological distress levels that reportedly cause them impairment in one or more areas of daily life. So it's already happening. We've got some very big problems here. I think one of the biggest ones is that this area is chronically under-researched and misunderstood. It's often overshadowed by physical health implications of climate change. Considerably more research is needed, as are proactive and targeted policy measures. So I'm looking forward to having a robust discussion about this in the small groups later. Thank you.
Great, thank you, Lawrence. That's really interesting. I didn't realize half of what you said. So I think that's it for the panelists' introductions. So now we move into the discussion and the breakout rooms. So it's going to be hard to choose, but please go to the room that you want to talk more about the area that you've heard about, and interact with the panelists and also with the other people in that room. Joe, do you want to say anything about that?
Just to say, yes, this is your opportunity now to speak to people, get their email addresses, brainstorm ideas, and remember there's potential funding to apply for. So set up some links and collaborations and discuss things now, and we'll see you in the breakout rooms. And then we'll come back at the end to close just for the last 5 minutes.